So in this problem, we wanted to look at the forces. Now we said to solve any of these problems, you need to do a free body diagram. So let's do this. But before we can do it, we have to find out what's going to happen. Well, if I look right here, I can see that mass 1 is bigger than mass 2. So if I looked at the forces, what's causing the motion? This is the force of gravity on these two objects. Which force of gravity is larger if we were neglecting the pulley overall? Well, M1 is bigger, so I know it is going to accelerate in the direction of M1. Also, this one will have a positive acceleration. If that's the direction of the boxes, that's also the direction of the rope. If the ropes are connected to the pulley, that's also the acceleration of the pulley. So now let's do this. The first one, I know I have gravity acting on the object, so M1G. Then I have tension going up. Now, here I can see that the acceleration is downward, so the downward force has to be larger. So I could draw a really small tension there. The next one, I have gravity going down. Now, the acceleration is going up, so the upward force has to be larger. Right. Now, the last one. What about gravity on the pulley? That is there. Then I have my tension forces going down. Right? One is tension 1, and one is tension 2. If I have 3 forces going down, I have to have another, let's say, call that the normal force or the pin force going up. Okay? So those are my forces with the understanding of the direction the objects move. Okay? The last thing we're going to get is, what if I had to compare across them? What about the two tensions? Well, let's look at the pulley to help us with that. So, which ones have a torque? Well, Fn and Mg do not have a torque because those forces go through the axis of rotation. However, tension 1 has a lever arm and tension 2 also has a lever arm, and they are equal. So, for this to rotate, one of these has to have a larger force. Okay. Which one is going to be larger? Well, we see over here that it rotates counterclockwise, so whichever force creates a counterclockwise torque will be larger. So, if that's the scenario in this diagram, I would see, that tension 1 is larger than tension 2. Okay. Now, in this piece, you can see I did not put these to scale, but it's hard to do it to scale across all of those. As long as with each individual diagram, we can see the consistencies to compare. So now, let's do our net force diagram for each scenario. Okay? The biggest part, I've told you before, you have to watch the signs. Signs will go in the direction of the objects. So this object's going down, that needs to be positive. This object's going up, so that direction needs to be positive. This torque is counterclockwise, so that needs to be positive. So let's do our F net statement in the Y, because that's the motion we're looking at for each of these. The first one, my downward force, M1G minus T1 equals M1A. Okay. The next one, that's going to be up is positive, so T2 minus M2G equals M2A. Okay. And lastly, my net torque statement. So for this one, I have to say the torque of 1, because that's my positive direction, minus, the torque of 2 equals I alpha. Right. So now let's keep going with these and figure out what I could do to manipulate them. Well, the first one, okay, to manipulate this, well, torque, that's tension 1 times its lever arm, which is the radius, minus tension 2 times the radius, which is its lever arm, equals I. I of a pulley is 1/2 mass of the pulley times r squared times alpha. Okay. Now, these are my equations. Right? I don't know tension, I don't know A. I don't know tension, I don't know A. Missing both tensions and alpha. So I need at least one more equation to do this. hopefully just by process you know my last equation that I need is alpha times r equals a. That way I at least get rid of one known. So let's do this. Let's say alpha equals a over r, and plug that in here. Okay. Also, I'm going to manipulate these equations to solve this one for tension 2 and this one for tension 1. Pause it, and I'll give you my answer here in a second. Later. So here you can see my two answers, and now all I need to do is plug this one in there and this one in here. Also, I'll show you what I have here. So again, pause it, get your new equation, and let's see what we have. So here I've plugged everything in. There is tension 1, there is tension 2, there is the alpha. Right? Let's do a little algebra now. This r cancels one of those, so now this has an r, this has an r, this has an r. Every term has an r. Whoa! The radius doesn't even matter. Right? So now I could simplify this. I want to put all the terms with a together and all the terms with g together. So over here I have m1g minus m2g minus m1a minus m2a equals 1/2 mass of the pulley times a. Right. So we can add these two terms to the other side, and let's see what I end up with there. And here I simplified everything over. Okay. So I've added all these terms. All those terms have an a. I factored it out. Now the really cool part, we actually aren't even going to plug the numbers in to find this. What we're going to look at right here is what is affecting the acceleration. This is really cool. So let's look down to this. Right. What's going on over here? This is just an F net statement. This is the net force, the net external force. Okay? That F net equals A times, we got to be careful, this is kind of like mass total. Notice I put quotation marks because it's not just the mass total, I have the half. Remember, for things to rotate, the distribution of the mass matters. This 1/2 is how the pulley's mass is distributed. So then we could ask you conceptual questions of how would I affect the rotation of this pulley? Well, what if I put a ring out there? Well, the ring just behaves as more mass. So as mass goes up, F net would stay the same. So if this pulley was a ring, the acceleration would have to go down. That's as far as you need to go on this. We'll ask you some more conceptual questions based off of this. Also, see if you have any questions in the algebra, but we'll come back to this one to help you answer some conceptual questions.